VLSos here. This is a video lesson on adding complicated fractions. But before we get complicated with it, let's remind ourselves how to add fractions in general with some simpler ones, like 1/3 plus 2/5. We can't add or subtract fractions unless they have the same denominator. We need a common denominator. And there are many methods to find a common denominator. The one that I always use is to multiply each fraction by a version of 1 based on the other fraction's denominator. This might be a time at which some people would think to cross multiply, but cross multiplication is not appropriate in this case. That would be a misapplication of cross multiplying. I'm going to multiply the 1/3 by a version of 1, which means something over itself, which is always equal to 1, so we can do it because multiplying by 1 doesn't change the value of a number or expression. And the version of 1 that I'll multiply the other fraction by will be 3/3. 3/3 is based on the other fraction's denominator. Why does this help? Because after I do this multiplication, 5/5 times 1/3, I multiply the numerators, multiply the denominators, and on the other fraction, 2 times 3 is 6, and 5 times 3 is 15 again. I'm guaranteed to convert the fractions into having the same denominator. And now I can do the addition step. If I add 15ths, the result will be in 15ths. Adding the numerators in this case makes 11. So there's the process of adding fractions. But what happens when the fractions that I start with are much more complicated because they contain algebraic expressions? Here I'm going to work an example 2x over x minus 1 plus 3 over x plus 5. These are fractions. We can think of them as rational expressions as well, and we're adding them. We can't add immediately because the denominators are not the same. I can convert these fractions into fractions that have the same denominator by multiplying by a version of 1 based on the other fraction's denominator. In this case, I'm going to multiply the 3 over x plus 5 by something over itself, a version of 1, based on the other's denominator. And the 2x over x minus 1 will also be multiplied by a version of 1 based on x plus 5. When I do, I will get the product of these fractions, the numerators 3 times x minus 1, but I'm going to group the x minus 1 because it's going to be 3 times the whole thing. And in the denominator, I'm going to group the two factors that I'm multiplying, x plus 5 and x minus 1. The first fraction becomes x plus 5 as a group times 2x, and in the denominator x plus 5 times x minus 1. And we can see that the denominators are now equal. So I can do the addition. Well, it's going to turn into one fraction whose denominator is the x plus 5 times x minus 1. And the numerators get added, so this is x plus 5 times 2x plus 3 times x minus 1. I've combined the fractions. I've done the addition. I might be able to distribute the terms, collect like terms, and maybe I could simplify it a little more. But I've added the fractions together, and I'm going to stop there for now. Treat the addition of complicated fractions exactly like you would a simpler form, and do it the same way.